number 10. I've decided not to write all over the questions. That would be horrendous. So here it is on neat lined paper. We want an expression for 8 sine to the power of 4 theta. So I'm going to take the equation they've given me for involving sine theta, I'm going to raise that to the power of 4. So 2i sine of theta to the power of 4 will be z minus 1 over z to the power of 4. 2 to the power of 4 is 16, I to the power of 4 is 1, and sine theta to the power of 4 is sine to the power of 4 theta. Then the right hand side, a little binomial expansion. If you know your Pascal's triangle, 1, 4, 6, 4, 1, you can use that. We're going to start with z to the 4, and then we're going to get z cubed times by 1 over z, which will be z squared. For the third part, you get z squared times 1 over z squared, which will cancel, leaving us with the 6, and so on. If you've taken more lines to do that, that's absolutely fine. So our 16 sine to the 4 theta, I'm going to rearrange the right hand side to pair them up. I'm going to pair up the z to the 4 with the 1 over z to the 4. And I'm going to pair up the z squared with 1 over z squared, factorising out minus 4 from that. And then leave the 6 alone. The reason I've paired them up like that is we have it given that z to the n over 1, z to the n plus 1 over z to the n is equal to 2 cos n theta. So z to the 4 plus 1 over z to the 4 is the same as 2 cos to the 4 theta. Z squared plus 1 over z squared is 2 cos 2 theta. And then if we divide everything by 2, we get the equation that was in the question. Okay, for part B, we're calculating the volume of this shape. So volume of revolution, rotating about the y-axis. So we're going to use pi times the integral of x squared dy. Okay, we know that x is equal to sine squared of a half y. So we are going to be integrating between 0 and 8 pi over 5. So sine squared of a half y, square that, we get sine to the power of 4 of a half y. And then we can use our answer from part A. Now, if we need an extra 8 in there, so what I'm going to do is take an 8th out, and therefore you can put an 8 inside it and just carry out the substitution. Obviously, theta is now a half y, so 4 theta will become 2y, 2 theta will become y, and we're integrating cos of 2y minus 4 cos of y plus 3, which is straightforward. It's going to be half sine of 2y, subtract 4 sine y, plus 3y, between 0 and 8 pi over 5. And let's plug those in. So half sine 16 pi over 5 minus 4 sine 8 pi over 5 plus 3 lots of 8 pi over 5. Substituting 0 in, straightforward. Sine of 0 is 0, 3 lots of 0 is 0, so no thought required there. And plug that in your calculator. If you do that correctly, you get 7.3 out, rounded to 2 sig figs. That's the volume of our shape. Now it gives us a little bonus question at the end with the density and the mass. So if we take our our volume, 7.3, and times it by the density, 0.85, it tells us that our model suggests that it would be 6.2 grams, which I think is pretty close to 6 grams, and therefore this is a reasonable model. A nice little question to finish off there. And that's the end of the paper. Well done if you managed to get through that last one. All right, bye.